Today we're going to be talking about parallel lines and proportional parts. So first of all, we are going to look at the triangle proportionality theorem. And so you're going to notice here that we have a triangle and we have an extra line drawn in that triangle, and that's line EB. Okay? And you're also going to notice that line EB and line DC here are marked as being parallel. And that's the first key piece of information, is that these two lines have to be parallel in order for the rest of what we're about to say to work. Okay? So if EB and DC are parallel, okay, so that's our if portion, EB and DC are parallel, then, this is what we're going to know, then we can set up this proportion. We can say that AB, which is this line segment, over BC would be proportional to AE over ED. Okay? And they're going to give you numbers in these locations or algebraic expressions, and you just need to know that you can set up this proportion and then cross-multiply and divide using that cross-products property that we talked about in 7.1. So at that point, you can then solve for whichever variable is missing. Okay? This one also works backwards. So if they had given you, okay, if they had given you this proportion, right, so this was given first, then you would know that those two lines had to be parallel. Okay, EB and DC had to be parallel. And so that's going to be really helpful as we go through and we just have measurements of parts of the triangle and we need to find out the measurements of other parts, or we want to know, do we have two parallel lines? And so it's really nice that we can do that, and that is the triangle proportionality theorem and then the converse of the triangle proportionality theorem. Okay, so next we're going to talk about the mid-segment of a triangle. So here we have this triangle. We'll go ahead and call it ABC. And you'll notice that there is a red point marked at the midpoint of each side of the triangle. Okay? If we connect any two of those red points, we get what's called a mid-segment. And this is just like when we were dealing with the trapezoids, right? We found the midpoints of the two legs of the trapezoid and we connected them and it created a mid-segment. We have the same thing going on here, only we can actually have three of those, okay? Because you could connect any two of the three midpoints of the sides and you would get a mid-segment. Okay, so why is a mid-segment important? Okay, so I'm going to erase all but one of them because we just want to look at that one by itself first. And so here we have a mid-segment, and they might tell you that it's a mid-segment in words, or they might mark that both of the sides of the legs, right, or both pieces of the legs, are congruent, like this, little tick marks. But either way, once you know that this is a mid-segment, you're going to know two things. Okay, so if it's a mid-segment, we're going to know, first of all, that it is parallel to the side that it does not touch. Okay, so this mid-segment touches line AB here and touches line BC over here. So that means that this mid-segment, and let's go ahead and name it. Let's say D and E. So it would mean DE is going to be parallel to AC. Okay? If we had chosen one of our other mid-segments, right, like this one here, then it would have been parallel to this side over here. Okay, so it's the side that it does not touch, and that's important. Okay, we also know that this mid-segment, okay, is going to be half the length of that opposite side that it doesn't touch. So that would mean that DC is equal to half of AC. Okay? That also means, if you were to think of that backwards, is that AC is twice as big as DE. So this is going to be a nice little formula here for you. is that you could take that mid-segment is equal to half of the opposite side, or the side that it doesn't touch, and you're going to be able to use that. Again, they may give you numbers in those locations, and you plug those in. They might give you algebraic expressions, so you need to be prepared for either one of those. Okay, so that was the triangle mid-segment theorem. All right. Okay, next we're going to be looking at some parallel lines, and you're going to notice that I have 3 parallel lines. So before, when we dealt with parallel lines cut by a transversal, we only had 2 parallel lines cut by a transversal. So now we're going to be moving into 3, and this is important in several ways. Keep in mind that while this picture looks like this right now, it could just as easily have been extended down, right? And you could have these lines running through a triangle, right? So it's all dependent upon how much we're zoomed into the picture, all right? And that's going to be important because it will come in handy with some of the other theorems we just talked about, and you're going to have to be able to recognize which one helps you the most, okay? So the first thing we're looking at here is that these 3 lines, AE, BF, and CG, are all parallel, and we know that because they each have a little triangle marked on them. And so if we know that these 3 lines are parallel, then we are going to be able to set up a proportion. So this is the proportion that we know we can set up. We could say AB is going to be proportional to BC, and that's AB over BC is proportional to EF over FG. And we're not saying that these are congruent at this point. We're just saying, hey, if you have these 3 parallel lines cut this way, then you could set up a proportion. And again, they might give you numbers or algebraic expressions. So they could give you X and 10 and 30 and 60, and you would go and you could plug those in, and you would get X over 10 is equal to 30 over 60, and you could cross multiply and divide and solve for X that way. Okay, so at this point we just know that we could set up this proportion. So you're going to want to be sure you remember that these 2 pieces on this side are proportional to these 2 pieces on this side. Okay, that's going to be really important. Next, we're looking at congruent parts of parallel lines. And what this one is saying is it's actually using our last theorem, the one we just looked at here, and we're just saying on this one, if I know that AB and BC are congruent, so that's just in the given information, and I know that these 3 lines, AE, BF, and CG, are all parallel, then I'm going to know that EF and FG have to be congruent. Okay, and you're asking, how do I know this information? Well, if you remember, in our last theorem, we said we could take AB over BC, and we could set up a proportion and set that equal to EF over FG. Well, guess what? If AB and BC are the same thing, then when we go to solve that, we're going to end up with 1 over 1. They're going to reduce that way. And they're going to equal EF over FG. So it doesn't matter what numbers or what expressions are there for EF over FG. Well, as soon as I go to do my cross multiply and divide, guess what? I'm going to be multiplying by 1. I'm going to be dividing by 1. I'm going to get exactly the same answer for both of them. So they have to be congruent. So all they've done is take our last theorem and extend it just a little bit farther. Okay? So we will work out some more specific examples of these tomorrow in class, and we'll look at how these can be used. And I really appreciate you watching this evening. Thank you, and I hope you have a lovely day. Goodbye.